Test in here on Wednesday. Did you guys do the review at all? Yeah. All right, some of you did, some of you didn't. That's all right. So test on Wednesday. I want to go through what's going to be on this test. Okay? So let's go section by section. Everybody take a look at page 5. Page 5. Those were the function questions. Yes, there'll be a couple questions on there. What's the domain? What's the range? Is this a function or not? What's the domain? All the x's. The range is all the y's. How do you tell if it's a function? X's are same x, different y. You can't have the same x with different y's. Or if it's graphed, we look for what's the vertical line test. That's really about all you're going to need to know out of section 5. Other than, there's going to be some questions, like if you look on page 5, there's going to be some questions like in the classroom exercises 9, 10, 11, 12. Where, how do you do number 9? How do you find f of 1? Plug in a 1. And then number 10, you plug in a 10, right? Okay, don't get the question wrong. Number 13. Just saying, there's got to be somebody that gets this question wrong. Okay, don't get f of a wrong this time. So just plug in an a, rewrite the function, you're done, right? Okay. Now, actually, here's what somebody's going to do. So the function's going to be something like this. 2x squared minus 8x plus 1, right? And then I'm going to say find f of a. And someone's going to go 2x squared plus 8x. And I'm going to go, and they're going to, well, actually they'll change them to a's. They'll do this. They'll go, all right, so that's going to be 2a squared plus 8ya plus 1. And I'm going to go, why? Why did you put a plus there? There's no plus. That should have been a minus. Why? There's no reason for that even a little bit. And now I have to dock points, and it's just sad. So don't do that. Okay? Easy? Okay, section 1, super easy. Okay, section 2, page 10, distance formula. Anybody remember the distance formula? Distance equals the square root of, subtract the x's, square it, plus subtract the y's, square that, right? Make sure you can use the distance formula. Is the distance formula when you take a square root plus or minus? Why? Or distances can't be negative. What about a question like 33? If I said find x and I gave you 1 point, the other point there's an x and a 9, and then I said the distance is 10. What would you do with that? Plug it in the distance formula. So we know the answer is 10. Okay, what's the first point? 1 and 3, right? And what's the second point? X and 9. Okay, how would I solve that? So I would square both sides, right? Get rid of the square root. So that's just going to be 100 over there. Equals, what am I going to have to do with this 1 minus x squared? Foil it out, right? Figure out what 1 minus x would be. Yes? Which would be what? What's 1 minus x squared going to end up being? 1 times 1 would be 1. You'd have a negative x would be negative 2x plus x squared. Yes? Plus, what's 3 minus 9? Negative 6. Negative 6 squared is 36. So now you got a quadratic. So we get everything on one side, and we kind of rearrange the order here. We got a 36 plus a 1 is 37. We're going to minus the 100, which gives me negative 63. And then we factor this. What is it? 6 and, no, 7 and 9? What? You got 1 plus that'd be, right, 60, 37. 37 minus 100. Yes? So what are my two answers here? Does it make sense that I have two answers? It does. Because what was the original question? What was the question here? I had a point. What was it, like 1, 3? Somewhere like right here-ish, right? And then it said the distance from that point was 10. Well, isn't the distance from that, like 10, going to be like a circle around that? Yes? What was the other point that we knew? We didn't know the x value, but we knew the y value was what? 9. So maybe up here. Well, how many times is that going to hit that circle? It's going to hit twice. Once is going to be at the point, what were my two answers? 9 and negative 7. So this point is 9, 9. This point is negative 7, 9. So yeah, generally speaking, those questions are going to have two answers, aren't they? Most of them. Does it make sense? That would be the hardest thing I gave you out of that chapter, or that section. Anything else from that? You guys, there will be questions like 27 through 32, where I give you a point on a circle and say, what's the equation of a circle? What's the easiest way to plug those in? X squared plus y squared equals r squared, right? Just plug in the x and the y, solve for r squared. Yes? Anybody want me to do one of those? How about, what's this one? 32? So they give you 3 root 2. And they give you, what's that, negative 4? Great. How do you square 3 root 2? What's 3 squared? What's square root of 2 squared? 9 times 2 is 18. 4 squared is 16. You add those together, you get 34. Do we really care what r squared is? No, because the answer is going to be what is the equation of the circle, which we already know r squared. So the answer is x squared plus y squared equals 34. Make sure when you do the distance formula, or if I ask you for the radius, you're able to simplify square roots. I don't want decimals on the test. It's going to be simplify square roots. So make sure you know how to do that. So we good with those? Okay. Flip over to page 15. Coterminal angles. How do you find coterminal angles? If it's in degrees, add or subtract 360. If it's in radians, how do you find coterminal angles? Add or subtract 2 pi. That's honestly, out of that whole section, probably all you're going to need to know how to do. For the coterminal angle questions, expect the ones where I ask you for like one positive, one negative, but also don't be surprised if I give you questions like 39 through 46, where I ask you for a coterminal angle, but I just want the one angle that's between 0 and 360. And again, just add or subtract 360 however many times you need until you're back within that range. Those are a lot easier to check that way because there's one correct answer kind of thing. Make sense? Easy? There will be, if you flip over to 21, converting. You need to know how to take 42 degrees, 13 minutes, 24 seconds, put that in degree decimal. You should be able to take 217 degree or 0.412 degrees and put that back into degrees, minutes, and seconds. You should be able to put 200 degrees into radians, and you should also be able to go 5 pi over 6 and put that back into degrees. Is there anybody that wants me to do one of these? Which one? All of them? How do I do this one? Just type in your calculator. Just make sure you know how to type that in. So, whoa, I got 2. You only need 1 calculator. You don't need 2. So how do I type that in? 4-2. Then what do I do? For this calculator, it'd be second apse or angle. There's my degree symbol. And then 13, go back to the second apse, hit number 2. And then how do I get seconds? Alpha plus. Oh, I need the 4. Alpha plus. So make sure you can do that. How do I do this one? 217. What just happened? Come back here. Don't be scared. 217.412. Then what do I hit? Second apse. The one that says the arrow DMS, the 4th one. So put it into degree, minute, seconds. So make sure you can do that. How do you turn degrees into radians? So I'm going to times this 200 by pi over 180, and then it's just a reducing fractions question. And again, I don't even care if you want to use the calculator to reduce the fractions, where you just go, what's 200 divided by 180? Don't put the pi in there. Math, enter, enter. 10/9, so 10 pi over 9. Just reduce fractions. How do you go the other way? 5 pi over 6. What's the easiest way? 5 times 180 divided by 6. Calculate that out. Easy? Questions on these? Those will be on the test, guaranteed. So we skipped section 5, but there is one type of question that will be on the test, and I can guarantee you there will be one of these. How do you find arc length? Just multiply the radius. So the radius times the angle equals the arc length, right? And all I have to, as long as it's in what? As long as it's in radians. So 10 pi over 11 times 8 is going to be 80 pi over 11. You're done. That's all you got to do. Those should be easy. Give me questions. Do I want you to put that as a decimal? Nope. Just leave it in pi. Good? You have to know your chart. You have to know your table. There will be another non-calculator part. It's going to be just like the last quiz. So make sure you know how to write out your chart. And usually at this point, everybody gets the numbers correct, but they screw these up. Either they flip-flop these and they put the 30, 45, 60 in the top, and they put the sine, cosine, tangent on the side, screws it up, or they put these wrong, and they put like 30, 60, 90. Like, no. So make sure you know how to do this. Know your quadrants. Seems like you guys have a good handle on your quadrants now. And your quadrantals. So make sure you can fill this out easily. Yes? You guys want me to fill it out, or are we good? Oh, you guys are quiet today. I don't know why you guys are so quiet. You gonna take the test tomorrow? Yeah. Yeah? No? What's up?
So for like the quadrantals, when it's sine, cosine, tangent, I know like what they are, but you flip them for the other.
For the reciprocals?
Yeah.
So, yeah. So these are, so it'd be what? 0, 1, 0, negative 1? So if I need to do the reciprocal of that, so if the question becomes, what is the cosecant of one of those? Well, you just got to be able to reciprocal. What is the reciprocal of 0? Undefined. What's the reciprocal of 1? No, still 1. So reciprocal of 1 is 1. Reciprocal of negative 1 will always be negative 1. Reciprocal of 0 is always undefined. The reciprocal of undefined is 0. So, yes?
What happens if it's like the sine of negative 1?
Sine of negative 1?
No, like the
Inverse sine of negative 1?
inverse sine.
When does sine equal negative 1? Well, 270. Make sense with those? So on this section, honestly, the biggest thing, so we're on section 6 right now. The biggest thing, well, actually, it's not section 6. That's more later. There will be a non-calculator part, okay? There was going to also be the questions where I give you sine is equal to 5, 6, and I'm in the second quadrant. You give me the rest. What is going on with my pen today? All the X, Y, R stuff. Good with those? Sine is Y over R, cosine is X over R, tangents Y over X. A lot of people on the quiz screwed up the tangent and had it X over Y instead of Y over X. So make sure you fix that. I let you guys keep your quizzes from the last quiz. Everything on that quiz is actually going to end up being most of the test. Non-calculator stuff, just what's the sine of 210? We're going to do a bunch of those tomorrow in class. I plan on getting the whiteboards out again, and we'll do a little showdown. Just rapid fire a bunch of those. Don't be surprised. I don't think I put really any of the reciprocal functions other than a couple cotangent ones on part A. Don't be surprised if I put a few more of those on there. So, look at page 37 again. 13 through 20. On the quiz, there was a bunch of people that messed up the quadrant questions. There's going to be some more of those on there. You need to know when sine is positive, when cosine is positive, and be able to answer those types of questions. Okay? There will be a couple of those on there. Yes?
Did you cosine equals secant? Like what quadrants was that?
Well, if it says, yeah, so if cosine equals secant, you know, again, on the quiz, I let you interpret that two different ways because I didn't really specify. If it's basically, if you read that as when are the signs the same, they're always the same, aren't they? Because if you take a reciprocal of a number, so if you put all four quadrants, cool. Or if you say what is x, and this is the reciprocal, what are the only two numbers that a number is its own reciprocal? 1 and negative 1. So 1 cosine is equal to 1 at a 0 degree angle. Cosine is equal to negative 1 at 180. So what quadrants are those in? They're not in quadrants. So I also accepted none. So easy enough. So XYR stuff, that will be on there. Non-calculator. And then, yes, so everybody take a look at page 50. All the calculator stuff. These are the ones that a lot of people screw up still. It's not the ones where it's sine of 47.2 degrees. Those everybody has a problem, are easy. The ones that a lot of people screw up, one, are these. How many answers should there be anytime you do this? Should be 2, between 0 and 360. Make sure you can find both. And then the other ones that a lot of people still screw up are the reciprocal ones. How do you solve this versus how do you solve this? So what am I going to type in my calculator here? 1 over cosine of 218. How many answers and what type of answer should there be for this? One answer, and it's a decimal, right? How many answers are there to this? 2, and what kind of answers are there? They're angle measurements, right? So we're looking for 2 different angles where this is true. So what do I type in my calculator? Inverse cosine of 1 over. Remember, if it's a reciprocal function, you must take a reciprocal. If it's an inverse, the reciprocal goes on the inside. Make sense? And again, 2 answers, 2 different angle measurements. Don't be surprised, there will also be a couple questions, again, similar to like the last few, like number 60, where there's 2 answers to the first part, but then the second part restricts you down to one or the other, right? There was a couple of those on the quiz. Expect there to be 1 or 2 of those on the test. Fair enough? It is a long chapter, but anything you want to see? All right.